So if you have a log equation, it's got two things. It's got the word log in it, right? And it's got an equal sign. That makes it an equation, right? A log part and an equation means equals, right? If it doesn't have those, if it has an exponent instead, kind of like these guys here, these guys don't have logs, have equal signs, but no logs, right? Instead, they have exponents. That's an exponential equation, okay? So if it's a log equation, follow these steps. If it's an exponential equation, you follow another set of steps, okay? So today, log equations, this is what we're gonna do. First step, combine. If there's multiple logs, combine them, condense them, right? Condense them. I should have put condense instead of combine because you guys seen that word before, okay? Condense and combine mean the same thing, same idea, but I should have put condense because you're used to that vocabulary. So condense the logs, put them together, okay, using three properties: product, quotient, power property that we've been using the last couple days. Okay, that's the first step. Second step, change it from a log to an exponent. Change it from a log to an exponent, right? We have steps for that. You have it in your notes. It's on the board. We've been doing that for a while. Let's see if I can bring it up here. See if I can find the notes. Just like this, right? Converting it from one to the other. It's color coded. So changing it from a log to an exponent. That's what we're going to do. We're going to go from right to left. That's that step. Okay. After that, solve for x. Isolate the variable. Okay. And then check for extraneous. We'll do that. We'll do those last. All right. So let's look at 1a. It's a log equation. How do I know that? Because it says the word log several times, twice, and it has an equal sign. So I know it's a log equation. So I'm going to use the steps for log equations. Okay. First step is condense or combine. So to condense, we use the three properties, right? Product, quotient, power. Okay, so I want you to take a look at this. Let's focus on this side right here. This side right here. Which properties can I use on this? Because I don't want two logs. I want one log, so I want to put them together. So which of the three properties or properties am I going to use to combine them? Product is one of them. Yeah, product. Yeah, Hayden, why product? You're right. There you go. That plus sign, right? Product. Good. What's the other property I'm going to use? Yeah, how do you know power, Brian? Not the 5. That's always there. That's the base. What else is there? The 2. Yeah, the 2. So I got to move that back. So when we're condensing, we start with power property. We start with power, right? It's in your notes. We start with the power if we're condensing. If we're expanding, we do that last. But if we're condensing, we always start with power. So let's start with the power. Let's move the power. This 2 belongs up here, squared. If we're condensing, it belongs up there. Okay. So 3 to the second power. What is 3 to the second power? 9, yeah. So let's change that to a 9. No more 2 in front. And we have a 9 there. Okay, good. We still have equals 2. Good. Okay, so power is done. Now let's use the product. Product says join them, but instead of addition, we're going to use multiplication. So I'm going to have log base of 5, only one of those, and I'm going to have 9x times 9, kind of like you guys did on Delta Math yesterday. Okay. 9 times 9 is 81. So 81x. So log base of 5 81x equals 2. Okay. Condensed. It's condensed. How do I know it's condensed? Because I only have one log. Okay, I only have one log. No more 2 logs, 1 log. Okay. Next step, change it to an exponent. Okay, so to change it to an exponent, right now it's written like this. Right now it's written like this, right? It's got a log. Log, base, answer, exponent, right? I don't want it written like that. I want to write it like this now. So the one you're looking at, what is the base? What is the base for the log you're looking at? 5, right? So 5 is going to be written like that. What is the exponent? 2 is going to be written like that. Equals, and then 81x is going to be written right here, right? Another way to think about it is the loop trick, right? You start with 5 to this power equals that. That's the loop trick. That works too. So 5 squared equals 81x. Now it has an exponent, no log. That's exponential, right? What is 5 squared? 25. So let me change that to 25. Okay. Done with that step. I changed it. Last step, or third step, isolate the variable. How do I get x by itself? Divide both sides by 81. Good. So I get x equals 25 over 81. I don't think it can be reduced. I don't think you can reduce that. I think that's it as far as it goes. It's kind of an ugly, don't change it to a decimal. Leave it like 25 over 81. Just reduce it if you can. If you can't reduce it, leave it like that. Okay. Done. That's step 3. Step 4 is check for extraneous solutions. Okay, so why do we have extraneous solutions? You guys remember from past tests are answers that don't work, right? They're answers that we did everything correct, but they do not work for different reasons. This one, why wouldn't it work now? We can't have negative logs. Can't have a negative log. Okay. So if I can't have a negative log, let's go back to the beginning. My answer. So was my answer positive or negative? Positive. So if I were to plug my answer in for x, if I were to plug my answer in right here for x, it would be multiply times 9, right? So what do the rules say? If I multiply a positive times a positive, what type of answer am I going to get? Positive. That's what I want. I want a positive log. Okay. How about over here? Is there anywhere to plug it in there? There's no x. If there's no x, I can't plug it in anywhere. That means it's always going to be 3. Well, is 3 positive or negative? So I get positive logs. So because I get positive logs, this is an acceptable answer. Enter, enter, green check. If you were to get a negative log, then it would be extraneous. You don't put that answer in. Okay. Doesn't happen a lot, but it does happen a few times. You don't want to have to do all the work and then put in 2 answers and then one of them's extraneous. You want to check that. Okay. You're only checking to see if you get a positive number or a 0. 0's okay. You can get 0. Or wait, can you get 0? Yeah, check that. Okay. Okay, so letter B. Okay. Okay, so now looking at this, first step. First step is the same. It's a log equation. So let's condense it. So if we're going to condense it, what are the, what property are we going to use? Division or quotient property, right? Division or quotient property. So let's do that. Okay. So when I do that, I'm going to combine these two guys using division. So now I only have one log with a base of 6. And I'm going to use division. So 9x divided by 4. Right? You did that. You guys did that yesterday on Delta Math. One log, condensed, done. Change it to an exponent. Okay, so when we change it to an exponent, you start with the base. Base to this power equals this. Okay, so 6 squared equals the fraction. 9x divided by 4. Okay. 36 times 6 is 36. So let's change this to 36 equals 9x divided by 4. Okay, so now I got to solve for x. How do I solve for x here? Start with multiplying both sides by 4. Good. Start with multiplying both sides by 4. So let me multiply both sides by 4, because 4 divided by 4 makes a 1. That's what I want. I want to change those to 1s. 4 times 36 is 44. There you go. Yep, that's what I got too. 144 equals 9x. There you go. Now I can divide both sides by 9, and I get x by itself. So 9 goes into 144. How many times? Was it 16? Yep. So this one gives me a nice clean answer. No fractions. Nice pretty answer, right? Doesn't mean it's going to be an answer. I have to still check it. Okay? So it's a positive 16. So when I plug in positive 16 here for x, right? Positive 9 times positive 16 is still going to be a positive number. And then over here, I have nowhere to plug it in. It's always going to be positive 4. So I'm good. 16 works. Green check. Good, good. Okay. All right, 2A. Okay, so here we go. Condense. It's a log. Condense. Which property am I going to use, or properties am I going to use to condense these two guys? Quotient again. Yeah, quotient again, right? So you're going to have a log with a base of 2, and then you're going to have 3x squared minus 3 on top, and 2x plus 2 on the bottom. And then that equals 4. Okay. Change it to an exponent. Base is 2. 2 to this power equals fraction. 2 to the 4th power equals this fraction here. Okay, so we did 2 to the 4th power, which is 16. Okay, so now, question is, what is our next step? We need to solve for x. We've done this before. We haven't done it in a while, but we've done this before, right? I have a fraction equal to 16. Well, I can make 16 a fraction. What do we do if we have a fraction equal to another fraction? We haven't done it in a while, but we have definitely done it. Multiplication, there's a word that comes before multiplication. What type of multiplication? Cross multiply, yeah, cross multiply. You're going to multiply diagonally across. So when I multiply the reds, the two red, I get 1 times 3x squared minus 3. So that's just 3x squared minus 3. When I multiply the oranges, I get 16 times 2x plus 2. I got to distribute the 16. I didn't have to distribute the 1 because it didn't change anything. So 32x plus 32. Okay. Got rid of the fractions by cross multiplying. What do we do now? We try to isolate it, right? The problem is with isolating, I have two variables. So I can't isolate them if there's two. So what do I do instead? There you go. Yeah, right there on the board. Set it equal to 0, factor out GCF, ABC, go on from there, right? It's a quadratic. It has squared in it. The highest exponent is squared. We've done that many, many, many times. So let's set it equal to 0. So I'm going to subtract 32 first because I can subtract that from negative 3. I get negative 35. Bring down the 32x. Now I can subtract 32x, but I don't have anything to subtract it from, so it's going to go right in the middle. It's going to be my b term. Okay. Set it equal to 0, done. GCF. Is there a GCF here? Can I divide them all by 3 or by 2 or by something? No. Yeah, I can't do 2. 3 doesn't work. 3 doesn't go into 32 or 35 evenly. So you can't, there is no GCF. Okay, so let's go right to ABC. So ABC, we have A is 3, B is negative 32, C is negative 35. Okay, so we're going to multiply first. A times C, when I multiply 3 times negative 35, I get negative 105. And then B is negative 32. So what are the two numbers that multiply to be negative 105, but add to be negative 32? These ones are here. Negative 35 and positive 3. Okay, so I'm going to move this over here because I'm running out of room. Okay, so I get x minus 35 and x plus 3. Okay. Not yet. Before I do that, I'm definitely going to do that. But before I do that, I got to do bottoms up because A is 3. So I have to divide by 3. If you don't remember, always do bottoms up because otherwise, if A was 1, this would have just been 1 and it wouldn't change anything, right? So make sure you always check for bottoms up. Well, 3 doesn't go into 35, and I can't reduce it. So that goes bottoms up. 3x minus 35. But I can reduce this one and divide this one. That makes a positive 1. Now I'm going to separate, set equal to 0, and solve. I'm going to get 2 answers. 3x minus 35 equals 0. X plus 1 equals 0. Okay, so we're going to get 2 answers. Add 35 to both sides over here. I get 35 over 3. Okay. One of them's negative, so that either one of them could be extraneous. We don't know until we actually look in the original problem. So I double checked. You can't have negatives or zeros. Negatives or zeros. Okay. So let's go back to the log. So I have -1 as an answer and 35 over 3. 35 over 3 is between 12 and 13. It's like 12.67. Okay. So if I plug in -1, if I plug in -1 here, I'm going to get -2. And then -2 plus 2, 0. So I can't have 0 as an answer, only positives. So -1 is not going to be an answer. It's extraneous. Okay, so let's try 35 over 3. 35 over 3, it's about 12 or 13. So if I plug in 12 or 13 here and square it and then multiply it times 3, that's going to give me a pretty big number. And then subtract 3, it's still going to be a pretty big positive number. Same over here. Here I'm multiplying and then adding it, still positive. Okay, I don't care what the answer, what the number I get is. All I care about is that I got a positive answer. Positive answer. So I only have one answer, and it's 35 over 3. Okay. Okay, last one. Last one. If we have time, we'll do a we will have time. We'll do one practice problem. We're not going to get to the last page of the notes. We'll do that tomorrow. Okay, I'm not worried about exponentials. We'll push off. I'm just worried about logs right now. Okay, we'll do those tomorrow. Okay, if I want to combine those, what property do I use? Product property, product rule, right? X minus 2, 4x minus 7. Okay. Done. Step 1, condense them. Good. Step 2, convert to an exponent. Base to this power equals these two guys. 3 to the first power equals these two binomials. Oops, already got an equal sign. Okay. 3 to the first power is just 3. Okay. So before I set it equal to 0 or whatever I try to do, I have to simplify, or have to, yeah, exactly. What am I going to do over here? Multiplication box. Good. Multiplication box over here. Okay. So multiplication box, because it's a multiplying a binomial times a binomial. I can't just distribute that because it's 2 terms times 2 terms. Okay. So 4x times x is 4x squared. 4x times -2 is negative x. Negative 7x, positive 14. Always combine like terms. Okay, so let me move them back. So I got 4x to the second power. Combine 2 like terms, I get negative 15x plus 14. Okay, no more parentheses. Okay, now I can set it equal to 0. Now I can set it equal to 0 by minusing 3 from both sides. Yep, the 3 was already there. The 3 was from 3 to the first power when I changed it to an exponent. Okay. So now GCF, besides 1, I don't think there's a GCF. So let's go right to ABC. A is 4, B is minus 15, C is positive 11. So we get 44 and negative 15. There you go. Yep. -4, -11. Those two multiply to be positive 44, and they add to be negative 15. So -4, -11. A is 4, so I got to divide by 4, bottoms up. The first one I can divide. -4 divided by 4 makes -1. The second one, I can't reduce it or divide it. So bottoms up. Okay. Separate, set equal to 0, solve. So I get 2 answers. I get a positive 1 and a positive 11 over 4. 11 over 4, if you divide, it's like 2.75, almost 3. Almost 3, 2.75. Okay. So if I plug them in, if I plug in 1 here, 1 minus 2 is a negative. So right there, negative or positive 1 is going to be extraneous. Okay. 11 over 4. 11 over 4, like I said, 11 over 4 is 2.75-ish. So if I plug in 2.75 for x here, 2.75 minus 2 is positive, 0.75. And if I plug it in here, it's going to be 11, I think. If I plug it in here, you'll get 11 when you multiply, minus 7, still positive. So the fraction is our only answer. Okay. All right, we got 13 minutes. I'm going to give you one more question in your notes. We're not going to tape yet because we're not done with the notes, but wherever you will tape in, do this problem here. Okay, I'm going to put it up here. Okay. Okay, so I did the first step. Condense them using quotient rule, division. Okay, now change it to an exponent. So it's going to be 4 to this power equals this. Okay, so 4 to the 0 power equals fraction. What's 4 to the 0 power? 1, positive 1. So I have a fraction on one side and a 1 on the other. So I got to change 1 to a fraction, cross multiply. Luckily, both are everything is being multiplied times 1. So the red is going to be 1 times x squared minus 4, which is x squared minus 4. The orange is 1 times 2x plus 4, which is just 2x plus 4. Set equal to 0? Let's see, set it equal, let's see, so subtract 4 from both sides. I get x squared minus 8, right? And then I got to take away 2x. 0 equals x squared minus 2x, that goes in the middle, minus 8. Okay. GCF. No GCF there, besides 1. Okay, so ABC. So -8, -2. What two numbers multiply -8? Had to be -2. There you go, -4, +2. Okay. Let's see, separate, set equal to 0 and solve. So we got +4 minus 2. So I get 2 answers. Will any of them be extraneous? -2. When I plug in -2, if I plug in -2 here, I get -2 times itself is 4, right? 4 minus 4, 0. Yep. So -2 will not work. +4 will be okay. Extraneous. +4, when I plug it in, I get 16 minus 4 is 12. 12, I get 12. Both of them are going to be 12. All right. Okay, we'll finish the rest tomorrow. Just put in your notes, slide them in your